we pick up with the last few examples in our notes today, please keep in mind the following bullet points. Again, that sine is the y value of a point on the unit circle. Cosine is our x value of the point on the unit circle. And tangent is the slope of a line at a given angle. And other angles with the same sine, cosine, tangent will have the same reference angle. Thus, we have to take into consideration symmetry within our unit circle when we are finding solutions. So heading back over to example 8 here, it's asking us to find all solutions such that sine is equal to -8/9 on the interval only in between 0 and 360 degrees. So we're not looking for all solutions, we're just looking for the two solutions that are in between 0 and 360 degrees. So let's take a look at this. I know that sine inverse of -8/9 has to give me my theta value. Notice that we are in degrees here. So when I'm using my calculator, I want to make sure that I'm finding degrees, not radians. So my degree value is approximately -62.734 degrees when we plug that into our scientific calculator. So here I've got making sure it's degrees, and now I'm going to insert -8/9. So again, we are in degree value here. We want to know in between 0 and 360 degrees, and this is not in between 0 and 360 degrees, so we would need to also, at this point, add 360 degrees, finding a coterminal angle. So from here, I'll add 360 degrees to that to give me about 297.266 degrees as one of my solutions. Now we need to know what the other solution is. And again, from that previous slide, we said that our sine values, again, are associated with our y values. And our y value is also negative in the third quadrant. So we have to look and reflect that as well. So I'm looking at my reference angle here. I know that from here to here is -627 degrees, but I also know that is the same as the coterminal angle of 297.266 degrees. So I can identify what is my reference angle, my green portion here, by identifying what is 180 degrees plus 62.734, because that would be our reference angle in the third quadrant. So my additional angle would be 180 degrees. That would go from our starting point to 180, but we have this other 62.7 degrees in here as part of our reference angle. So adding 62.734 to this, our additional angle is 242.734 degrees. So we found both of the solutions in the interval between 0 and 360 degrees. Example 9, here we're wanting to find all of our solutions between 0 and 2 pi. So recall that tangent only has one solution per cycle, and their cycle is within pi. So if I'm looking for x, I need to find the inverse of tangent of 3. And because I'm using pi, I'm in radians. So when I go to my calculator, this time I want to find the inverse of tangent of 3. I'm going to flop that over to the radian solution. So this is about 1.249 radians. And this is going to be the first solution. Now, I also know that tangent is going to be positive in my third quadrant. right? It's going to be positive in my third quadrant. So if I kind of draw a reference angle here, we'll say from here to here, again, is about 1.249 radians. My other angle is going to be in the third quadrant. So I would need to add pi to that to find the degree or the radians within each cycle. So tangent, let's just make note of it here, has only one solution per cycle. And I should say per pi cycle because that's its period. Thus, I could find the next one by saying 1.249 plus pi, or 3.14159, 4.391 radians. And so we found two solutions between 0 and 2 pi. We could also utilize our graphing calculator to assist with this since we are in radians. So if I start off by saying y is equal to tangent of x, and our second one is y is equal to 3, where do these two, here we are. So looking, my radians are down below here. 2 pi is going to be 2 times 3.14, so about 6. So down here again is where we're going to start. Here's 2 pi. So the two solutions between 0 and 2 pi are in fact exactly what we had indicated, 1.249 and 4.391 that we had indicated algebraically. So great tool to help us. Here we have 3 times cosine of t plus 4 is 2. Find all solutions in one cycle because cosine repeats its cycle every 2 pi. Again, we still want to isolate our trig function. So I'll start with 3 times cosine of t, and I will subtract 4 from both sides, giving me negative 2, and then divide by 3. So cosine of t is negative 2/3. We are in radians because I have pi here, so when I plug this into my calculator, we want to make sure we're in radians first. Thus, t, in order to solve for t, is equal to the inverse of cosine of negative 2/3, which is approximately 2.301 radians. So I can come back over here. It's clear. We have cosine inverse of negative 2/3. I'm in radians. We could plug that into degrees, which is about 131.8 degrees. However, we want our radians. So we also know that cosine, again, is associated with our x values. So this is in the second quadrant, because notice I have 131.8 degrees. That is in the third quadrant. So we know we're also going to be, our x values is also going to be negative in the third quadrant. So we have a reference angle in the third quadrant. So let's talk about what that looks like as a reference angle. So right now we're over here somewhere, and from here to here is 2.301 radians. So my triangle kind of goes like this. So my reference angle or triangle is in the third quadrant. So I'm interested in what is the degree value from, or the radians. I also know that from here to here would be negative 2.301 radians. So then I could identify the second portion by taking 2 pi minus 2.301 and receive approximately 3.982 radians. So from there to there is approximately 3.982. Example 11. Now noticing it's asking us our interval has changed. So we're looking for all solutions on 2 cycles between 0 and 4 pi over 3. So notice this time I've got cosine of 3t is equal to 0.2. So we're going to have to do that u substitution again to help us identify these portions. So bear with me here. We're going to let u equal 3t. Thus, cosine of u is 2/10. I can solve for u by saying cosine inverse of 2/10. And this is going to be approximately 1.369 radians, since we are in fact in radians here. So I know that cosine, again, our x value is positive in the first quadrant, and 1.369 is certainly in the first quadrant. So between here and here is 1.369 radians. I also know that I'm going to be positive in the fourth quadrant, so I need to know what is the angle from here to here. So to do that, I can find this by taking 2 pi minus 1.369, which would be the distance from here to here. And we would get approximately 4.914. So those are our 2 solutions. Also, we're looking for the second cycle. So these 2 are associated with the first cycle. We need to go around again. Thus, u has to equal 1.369 plus 2 pi, which is approximately 7.653. And u also will have to equal 4.914 plus another round for the second cycle, or 11.197. So these are the second cycle around. But if these are equal to u and this is equal to u, we're not finding u, right? We're finding t. So I need to set 3t equal to each one of these solutions. Finally, dividing each value by 3 to get t by itself. T will be equal to 0.456, 1.638, 2.551, and 3.732. 2 cycles around. I also could double check that 4 pi over 3 is 4.188 radians. Our largest value does not go over that, so we have 4 solutions in 2 cycles. Let's try another one like that, except let's utilize all solutions. So example 12. 3 times sine of pi t equals -2 for all solutions. We still want to isolate our item here, so I'll divide each side by 3. So sine of pi t is -2/3. Since we have something inside and not just a whole number, we do have to utilize our u substitution. So I'm going to let u equal pi t, a little different than what we have been utilizing thus far. But I'm looking for sine of u is negative 2/3. So I know by definition, u has to equal the sine inverse of negative 2/3. It doesn't say, we probably should stick to radians because we do have pi and pi is radians. So we'll stick with radians. And this is equal to negative 0.730 radians. So when I think about where I am here, from here to here, because sine is negative in the fourth quadrant, our y values, here to here is negative 0.730. I'm also negative for my y value in this quadrant. So these two angles are symmetric. That means I need to find what is from here all the way to here. Well, I know I could find that by taking pi plus 0.730 because I know these two are symmetric. One is going to be positive and one is negative because of the direction I'm going counterclockwise. So I have 180 degrees. That gets me from here to here, and then plus another 0.730, which is approximately 3.871 radians. We are looking for all solutions. However, we haven't solved for t, right? We've only solved for u. So pi t is equal to negative 0.730 plus all multiples of 2 pi. I could easily get t by itself then by dividing everything by pi. If I were to take negative 0.730 divided by pi, we have negative 0.232 plus multiples of 2, since our pi will end up disappearing. I also have pi t must equal 3.871 plus multiples of 2 pi. But to get t by itself, we'll divide everything by pi. 3.871 divided by 3.14159, etc. gives us 1.232 plus multiples of 2. Since we are in radians, let's take a look at what this might look like on our calculator. We have y is negative 2 as a solution, and then we have y equals 3 times sine of pi x, of course. And we're all solutions. Okay, so down here is where it looks like we're connecting. And here. So notice here we start with our negative 0.232 because that is where the cycle is starting. It is shifted a little bit. Here is our next solution at 1.232. And then if I add 2, multiples of 2 will end up with a series of solutions that are mimicking one another, which is where these are coming from. Similarly, if we go back to example 11 and graph that picture, we have cosine of 3x equal to 0.2. And here we're going between 0 and 4 pi over 3. Our first solution, as we had anticipated once we did all the algebra, is in fact 0.456. Our second solution, 1.638. Our third solution, and then our fourth solution certainly match. 2 cycles again between adding 2 pi to each one. This one would have been just slightly over our requirement, but kind of a great way to be able to see how our graphing tool can help us visualize what we are solving algebraically for peace of mind. And our last example, the height of a rider on the London Eye Ferris wheel can be determined by the equation the height is equal to negative 65 cosine pi over 15 times t plus 70. How long is the rider more than 100 meters above the ground? So we're looking for where are we at 100. So currently we're interested in when the height itself is equal to 100. So we'll solve this for negative 65 times cosine of pi over 15 t plus 70 is 100. And then we'll go from there. I can subtract 70, thus negative 65 times cosine of pi 15ths t is equal to 30. Divide by negative 65. Let's see, negative 30 65ths. We'll just leave it at that for now. We need to use u substitution. We need to use u substitution because I don't just have a single variable on the inside of my trig function. So u is equal to pi over 15t for now once we get started. All right, I can find u then by saying cosine inverse of negative 30 65ths. We're in pi, so that's our key to use radians. So we're at about 2.051 radians. Well, cosine, I know, is directly associated with our x values, and I know that I'm going to be negative for my x values in the third quadrant. So here, from here to here, is 2.051, my reference triangle. I also know that I'm going to have a negative value in my third quadrant, so I know from here to here is negative 2.051. So I could find my other angle by saying 2 pi minus 2.051, which is approximately 4.230. So this is my u values, but I'm not solving for u, right? I need to solve for t. So I'm going to take pi over 15t is equal to 2.051, and pi over 15t is equal to 4.230. And of course, solving for t, I will multiply everything by 15 over pi. So when I multiply my first fraction here, t will be left over. And we obviously going to use our calculator. So time is 9.793. I'll do the same here. And here, using our calculator to help us multiply, 20.197. So time represents after the rider has started. So in between this time and this time is the time when we will be above, right? Because of the direction of how cosine is swaying. So when I take 20 minutes, 197, unless t is in seconds, I would assume minutes. We're going to assume minutes. 10.404 minutes, we are above (100 meters). So let's look and see what this might look like graphically to help put some of these pieces together. All right. right, so we have the equation y is equal to negative 65 cosine of pi over 15x plus 70. We will have to renegotiate our graph here is 100 because we can't see anything, right? We can't see anything that's happening yet. Oh, here's our graph starting, but what we'll do is just zoom out a little. There's our graph. Okay, here is our graph. Specifically, we're looking between 9.71 and 2.029, because noticing that if we think about the Ferris wheel coming back up and coming back down here, we'll see that starting at 9.791 seconds, we are going up. We are above the 100-meter mark because the y values are representative of the height. And then we reach 20.29 seconds after the ride has started, and we are then back, or I'm going to say minutes, and we are back down at 100. This could be seconds, I guess. It just depends. It doesn't specifically say. So whether it be seconds or minutes, in between 9.791 and 20.209, we are above the 100-meter mark. So by subtracting these two values, we are determining how long we are above that 100-meter mark. And that completes our lesson on 6.4. So please utilize that calculator to help you verify what you are doing algebraically is matching what we can see visually with the graphs when we are in radians.